All right, well, welcome everyone to the Everything Microsoft Windows. I'm William Yu, I work for Xojo, and I'm a software engineer there. Everything. We don't have time to cover everything Microsoft Windows, but what we will cover is some of their technologies. We'll talk about the OS features, some of the other OS features like HDMI, high DPI, ActiveX, COM, DWM. They've also introduced last year example islands. We'll talk about that. UWP and the desktop app converter. We'll also talk about the frameworks, some of which you might recognize. Win32 is what we use. And we'll talk about COM components, WinRT a little bit, and some other frameworks as well. So let's begin by talking about Windows XP. It was first introduced in 2001. It introduced visual styles and themes. You could choose a classic theme, or you could choose to enable visual styles, which enable you to have different colors. It also introduced GDI Plus, and GDI Plus was supposed to be a replacement to GDI. It added support for alpha channel, anti-aliasing, and it also introduced a new text rendering engine. So let's talk about Windows XP and Xojo. Well, we no longer support Windows XP. We actually dropped support for that in 2015 R3. And we also dropped GDI Plus support in 2016 R4. And we used Direct2D as its replacement. All right, Windows Vista and 7 introduced the DWM, also known as the Desktop Window Manager. This actually helped composite your app a little bit, and also introduced the Arrow Glass theme, which added translucency to your window. Also introduced Direct2D, which we use today. High DPI was introduced. WPF, the Windows Presentation Foundation .NET Framework UI was also introduced then. So let's talk about how this affects Xojo. Well, we dropped support for Vista in 2016 R1, so we no longer support that. We do support high DPI, and we've recently upgraded our graphics to Direct2D and DirectWrite in 2016 R4. In terms of Windows 7, you probably know Microsoft is ending support next year in January, but for Xojo purposes, I'm sure we'll continue to support it for a little while longer. Windows 8 introduced the Metro UI, now known as UWP. It dropped the classic theme and also the arrow theme. DWM, which was introduced in Windows Vista and 7, was actually optional in that operating system, but in Windows 8, that became permanent. And they also added support for per monitor high DPI support. They introduced the Windows Store, so you can add your app to the store and have other people download that way. WinRT is the Windows runtime. If you think about it, it's the object-based equivalent to the Win32 API. And they also switched their C Runtime and added the universal C Runtime, which we also take advantage of. So as mentioned, we switched over to using the Windows Universal C Runtime in 2016 R1. Around that time, we also added support for per monitor high DPI support. And you can access the Windows runtime, call it WinRT, through several COM components that they expose. So WinRT is the unmanaged framework, unlike the .NET framework. So you can access WinRT through our unmanaged Win32 app. Windows 10 came next. As you know, it was a free upgrade for those that own Windows 7 or Windows 8. So there were a lot of people that took advantage of that. UWP was introduced, or I guess the Metro UI was rebranded as UWP. And UWP is their preferred platform target. It supports desktop, mobile. I guess mobile's dead now, but Xbox and other platforms. Microsoft also worked on this project called Project Centennial. They sensed that a lot of developers weren't moving their Win32 apps or their WinForms or WPF projects over to UWP, so they added this thing called the Desktop App Converter as an easy way to convert your Win32 apps to UWP. It actually just made your app be known as a UWP app, even though it didn't convert your controls to UWP. Last year, they announced support for embedding UWP UI controls in Win32 apps, WP apps, WinForm apps as well. So with this new COM feature that they're going to add soon, you'll be able to embed UWP controls into your Win32 apps. And they do have developer builds that you could, or preview builds of the Windows operating system that has this support. So you can play with that before it gets released. So let's talk about the Windows desktop apps. There are several ways you can create a desktop app on Windows. There's Win32, which we use. There's MFC, which are classes on top of Win32 APIs. And then the latter three are the .NET framework managed code side of things. They have WinForms, which uses Win32 controls, actually. They have WPF, as we talked about. That is a composited UI, which allows you to overlay controls just like on the Mac without any issues. And then they have UWP, which is the preferred target. So let's talk about some of these options. So for UWP, you're pretty much constrained to Windows 10. It did not exist in Windows 8 or Windows 7. And their UI is created by this markup language called XAML. WPF is the Windows Presentation Foundation layer. And what's nice about WPF is, as I mentioned, it's composited, so things work pretty well. WinForms is our closest equivalent. It uses this thing called pseudo-transparency to reduce flicker like we do. And it is really closest to the Win32 UI. All right, so let's talk about Win32 and what it offers. So Win32 is not a managed runtime like a .NET WinForms or .NET WPF. So we don't depend on a managed runtime. It really is the highest level of performance. It has direct access to the hardware. It can also host WPF controls, and now soon UWP UI controls as well. It's got access to the Windows runtime, and it is native. So you'll see the visual styles and everything just works with all the themes. It's composited via our own pseudo-transparency model. As I mentioned, it supports the themes and styles. We could use Direct2D and DirectWrite for our graphics. We support per monitor high DPI support. Not sure why I keep saying HDMI, but it looks so close. We also support the universal C Runtime. We support ActiveX and COM as well. So the big thing with the introduction of Direct2D and the flicker. We introduced the pseudo-transparency model, as I mentioned, last year in 2018 R1. So what this means is we handle the compositing for you. Some of the disadvantages or downsides is that we lose true transparency. So if you partially overlap two controls, that no longer works. So avoid that. Avoid transparency on animated controls. And we decided on this model because WinForms uses it and it seems successful. So let's take a look at this new model. Some examples to show you. All right. So let's start with everyone's favorite, a scrolling example. So before we introduce this pseudo-transparency model, what would happen is a lot of controls would flicker as we move them because it would draw the background. But with this approach, we're compositing that drawing for you. And so you'll notice that scrolling is a lot smoother. Compared with, I do have a build that was not using this model, just to demonstrate what that looked like before. So before this change, this is kind of what people would experience, where things would flicker because we're drawing the background and then the control itself. So you can see how ugly that looked. Yeah, really ugly. Okay, so that's the benefit of moving to the pseudo-transparency model. Now take a look at some of the differences between these two models. One big difference is this overlapping issue. So I got these two windows. As you notice, I have these two basketballs overlaid, partially overlapped. This is called partial overlapping, where one is not contained within another. So I got these two partially overlapped canvases. And in the project, they're transparent. But when you run it, because of this model, what you'll see is that we've lost true transparency. And so it's really not completely transparent. It will be if you parent that canvas into the other canvas. But when you partially overlap things, it's not going to work. All right, and the second example is going to show you is placing controls or canvases on top of animated controls like this is not going to work either. You can see this house is actually a canvas, and it's also no longer truly transparent. So let's take a look at what that looked like before this change. So before this change, things did work. Things were truly transparent, and this house was transparent. So as the progress bar moves over it, it's fine. However, DWM is doing some compositing for us, so it's not flickering right now. But notice if I start moving this separate window, not even related to the first window, and how that house just flickers. Because DWM is not compositing that quickly enough for us. So you get flicker. So avoid those situations if you can. All right, so the last example I want to show you is also a scrolling animated issue. So let me show you what this looked before. I'm simply scrolling a canvas across the window. And before the pseudo-transparency change, we got this huge flickering effect as we draw the background, draw the canvas, and draw the soccer ball canvas as well. And so you got all this drawing happening, not composited, so you get all this flicker. All right, quit that. And now with the new pseudo-transparency model, since we're doing the compositing for you, it's much smoother. And since the soccer ball canvas is contained within this window, I guess it's not a canvas, but you can see it draws pretty well as I resize. All right, so those are some of the differences and some of the advantages that we get from moving to this model. Any questions so far? All right, so what have we learned from doing this? One thing we've learned is don't make your controls transparent is really the best practice here. The more transparent controls you have, the more compositing you have to do, the slower your app will get. So if you can avoid transparency, again, do not partially overlap controls. You can contain controls within another control. That's perfectly fine. But partially overlapping controls is not going to work as you expect. Another thing we added to the control is this double buffer feature. And this actually turns on a feature in WinRT that actually does compositing. The reason why we don't do this on a global scale is because WinRT compositing is actually very slow. So if you really need WinRT compositing, you can enable this double buffer property on the control. But notice that your app will kind of slow down because WinRT does its own compositing. So the only real need for doing this is for much smoother scrolling. Other ways to achieve smoother scrolling is you can also trigger refreshes. You can also decide to not redraw everything as you scroll. And doing this helps with just refreshing once instead of many, many times. And there's the declare or API to do that. All right, so let's talk about Direct2D and why we moved in that direction. So Direct2D is a replacement for GDI+. It's high DPI ready. So the drawing is queued. You'll notice in GDI that each time you initially call a GDI function, it draws immediately. But with Direct2D, everything is queued. And this queue is flushed when the graphics is released. And by released, it could be when the paint event completes. Or for pictures, it's when you draw the picture or when you actually use the picture in some way like that. So with Direct2D is nice because you can actually use GDI calls to mess around with it, but this is really expensive. So if you need to get the graphics handle and you get the HTC handle and you directly draw to that HTC, things will slow down. And so I would recommend avoiding that interrupt if you can. All right, as I mentioned, GDI Plus introduced its new text rendering engine, which we didn't like. It had many issues, including being really slow. And so in general, when we store GDI Plus, we actually drew text with GDI. But with DirectWrite, we found that the text rendering was just as quick as GDI, so there wasn't any problems there. Again, it's high DPI ready. You can draw at pixel fractional pixel boundaries. And there's actually two rendering modes. We can make it draw like GDI, or we can make it draw as its default. And just like GDI Plus, when we use GDI for text rendering, we use it everywhere except for pictures with alpha channel, because GDI cannot draw text onto pictures with alpha channel. And just like DirectWrite, the same thing applies. We use GDI compatible text rendering everywhere, except if you have a picture with alpha channel, then we have to use DirectWrite's default text rendering mode. All right, so let's talk about high DPI for a little bit. So for 64-bit apps, we have this manifest that's included with every executable. It tells the operating system that we support high DPI. And we've recently updated this for 32-bit apps as well. So with high DPI, unlike the Mac or Linux, on Windows, it supports fractional scales. So you gotta worry about the anti-aliasing effect. If you're drawing on a fractional pixel, it's gonna alias that drawing. And just a quick note about picture horizontal and vertical resolution. When you're loading a picture from disk, and some pictures might not have DPI information stored in that picture, we'll load it, the operating system loads that picture as 96 DPI resolution, which is different from Mac and Linux, which will load it as 72 DPI. So make sure your pictures have DPI information stored, or if they don't, then you probably want to normalize the resolution. All right, so universal C Runtime was introduced in Windows 8.1, but they also backported it to Windows 7 with the SP1 update. So for your purposes, when you create apps with Xojo, you'll either want to create an installer to install these runtimes on the user's system, if they're not already installed. There's a redistributable executable in our extras folder. You can find that in extras Windows. There's also an option in the IDE where you can choose to build your app with these DLLs next to it, and then you can just distribute that to your users without having this redist. All right, so we support ActiveX and COM, so let's talk about that. We use it for our HTML viewer, our native one. We use it for the movie player. Direct2D is actually built on top of COM, and also spelled that wrong, but drag and drop. And if you're using the Windows IDE, you can find a bunch of ActiveX or COM components listed under the Insert ActiveX component menu. And here's just a list on my computer. And when you add that control onto your form, we actually draw the UI for that as well. So almost like a plugin. All right, so let's talk about some of the COM features that Windows provides. So the taskbar progress, as you might see when you load a project in the IDE, there's a taskbar with the icon on the bottom. And as the IDE is loading a project, you'll see the progress also appear in the taskbar area. So that feature uses COM. Other features you can use is extending folder items to delete the folder recursively. Currently, we don't provide that feature. You have to delete all the individual files and then delete the folder. And then there's this Windows Runtime, which is a framework much like Win32, except object-based. It's unmanaged, so you can access it in Win32 without any issues. And it's based on COM with some extended features. If you know COM, all the objects are based on IUnknown. With WinRT, they've added the inspectable interface, which is their base interface, and it provides additional features that IUnknown does not. And with the Windows runtime, it supports a lot of features. One of the features that might interest you is toast notification, which is that notification snippet you get on the bottom right-hand corner of the screen when something happens, like Windows Update or a Slack update or something like that. All right, let's run through some of these demos. All right, so the first demo I just want to show you is a taskbar. I have this taskbar class I created, which inherits from the base COM interface, which is IUnknown. And the meat of it is in the constructor. Now, if you don't know COM, don't worry about it. Really, essentially what you need to know is what's the ID of this class. And so while this might look ugly, you can find this fairly easily either by poking on the web for the taskbar list class, or even in the registry, it'll have that ID for you. So we have this COM module. We have several features in the COM module. One of them is this create instance function, which creates the class for you and returns a instance where you can use to call the COM class using function pointers or delegates in this case. All right, so let's take a look at what this looks like. So the two main things to look at is this window right here and this little icon down here. So right now I don't have any progress. I move the slider, you can see that updating down there. There's also the error progress, which looks red. And of course, they have the indeterminate progress, just like a indeterminate progress bar. So all that was done in Xojo using COM. And as I talked about too, extending features, you can, in this particular case, I've extended the folder element class to delete a folder recursively. And again, it's just a bunch of COM components. Once you find the ID, that's probably the main task, I guess. And after you've found that ID, creating the class is fairly simple. We have some of these documented. You can also look on MSDN to find more documentation on how to use these functions as well. So in this example, I'm demonstrating how to extend the folder item by deleting recursively. And with this COM component, what it also offers is a way to see the UI, so we can see the progress on how quickly this folder is being deleted. So here I have two buttons, one that uses COM and then one that just purely uses our folder element class. So I'm going to show some UI here. I'm going to delete these folders. You have to believe me, these two are exactly the same. So I'll delete this one. They'll ask me if I really want to delete that. I say, sure. So that UI was all provided by this COM component. That took about 7 seconds. Or I can delete it with our internal forum class. And see how long that takes. That took a lot, that was much quicker. I think mainly because there was no UI provided. But yeah, so you can extend features using COM. You can do a whole lot of stuff because COM has a lot of components that's already installed on your system. Okay, any questions about ActiveX or COM?
Will these be available to suppose when they have access?
Yes, I believe they're even in the examples project folder in Xojo. But if not, I believe Dana sends out these slides with projects as well, example projects. If not, come talk to me. I can get these to you. All right, so what are the best practices for using ActiveX controls in COM? So with ActiveX controls, you'll probably want to create an installer. Not everyone's going to have the ActiveX controls installed on the machine, so what you can probably do is create an installer that installs that control for them. Again, if you're familiar with COM has two modes. You got the vtable, direct function pointer access, and then they also have this interface called iDispatch, which is used by a lot of scripting languages. It provides this interface where you can communicate with a COM object via this invoke method, they call it, by finding its function index, using some call I can't remember right now, but it's if the COM object supports that interface, you can use OLE object to access that, and it's much easier than using vtable binding. And by using the OLE object, you have access to other features that you can use, like OLE parameter, which provides the ability to pass parameters by index. So if you ever use VB, you can call a function and you can name the parameter and pass that value. So you can have like 5 parameters for this function, but you can call it just the middle parameter by name. And so this OLE parameter kind of mimics that. Again, you can pass by name or position. So extending features on Xojo, or when you want to extend features, you can use declares. You can add other Win32 controls. We have Win32 provides a bunch of controls which we haven't added to our project because either there's no support for that in other platforms or what have you, but you can use declares to extend our product. You can also use declares to call this API to suppress redraw. And again, you can use COM to extend our features like we did with that folder M. You can add ActiveX controls. You can also access the Windows runtime with COM as well. I talked a bit about this yesterday, but you can add WPF controls into your Xojo app via a plugin. The main thing is getting the .NET framework linked into your app, and when you create this plugin, that plugin will have the .NET framework that gets linked into your app. So if you create a plugin that uses .NET and you link it with your app, you automatically get that framework. So I'll show you an example of what we did to add a calendar and a text field using a plugin that uses WF. All right. Go back here. Okay, first, I just want to show you how we've added a new WinRT control. So we don't expose this command link control, which is part of WinRT2. And what command link is, you might have seen it in the system preferences. It's a lot like this, where it's pretty flat looking, and when you hover it, it does something. So that's kind of like a command link button. So the parts I want to show you, probably in here. All right. So again, if you don't understand WinRT2 declares or APIs, don't worry about it. What I'm trying to demonstrate is how you can use declares to quickly add additional features to Xojo. And in this case, I'm just creating a window, and this is actually the command link window. And I'm embedding it onto a canvas. So the canvas is my host for this control. All right, so let's see what that looks like. All right, so with this command link button, I can add an image to it. And as you can see, as I hover over the button, it animates. Might be a little hard to see the animation. Yeah, I can click on it and it returns an action. Okay, so that's an example of using declares to extend features in a product. Now let's look at Windows Runtime. Okay, again, as I mentioned, Windows Runtime, to access Windows Runtime, you go through COM. And it's a little different in that instead of, you might have noticed in the previous example, I had com.codecreate_instance to create that COM object. With Windows Runtime, they're looked up by class name. So to find a class name, you either read their documentation, you look at their headers. In this case, I pulled up their headers and I found this calendar class. And pretty much all their Windows Runtime creation functions live in this com-based DLL. So I'm declaring against that to create an instance of this globalization calendar class. Again, with COM, this COM interface doesn't expose iDispatch, so there's no way I can use only object with it. So I'm using direct vtable binding, which means just a bunch of ugly delegates. So you use delegates to access function pointers. So I'm using delegates to access the methods in this class. And here is one of its functions to get what kind of calendar system it's using. So essentially calling this function pointer. And I know it lives, a couple functions down. You can poke at the header file of these classes to determine the function location. So anyways, let's take a quick run of this project. So here I'm just returning what calendar system they're using, which Windows RT is using the Gregorian calendar, and I'm just returning the year. Just 2019, that's correct. Okay. All right, so as you can see there, looks like a bit of work to access Windows Runtime, but it's all doable. It's just COM-based, it's not managed, so you don't have to worry about linking in .NET Framework. Okay. Any questions about those demos? Okay. All right. So finally, some Windows tips for you guys. Preferences. If you want to store them anywhere, I would recommend storing the registry under HKey local machine /software. And if you want it to just affect the user, then you want to put it into HKey current user /software instead. With debugging, we have our messages pane where you can output system.debug log. For built apps, you can also use debug view, and that'll log all the system debug log lines that you have in your code. With Windows error reporting, this helps us in that if your app crashes, you can hit send when the dialog pops up to send crash dumps to us without having to generate yourself. So if you have that enabled, that's great. And if you click on that send button, that'll send that crash dump over to us. So, and if you don't have that enabled, I think Paul has some documentation on the docs site where you can enable mini dumps. So if your app crashes and you want to send us that crash dump, saying this registry value to enable these mini dumps, you can find that and then just submit it to a feedback case, for example, and we can resolve that crash dump. Just a few more tips. On Windows, if you want to support single instance apps, you'll probably want to use a mutex and check it to make sure if it's locked. If it's locked, then bring up your other instance. But in general, on Windows, there's a lot of multi-instance apps that just behave that way. So it's up to you how you want to support that. So with declares, if you have a DLL that you want to distribute, you can stick it into your libs folder. You can also stick it in the current directory of your executable. And of course, last case, you can create an installer that installs that DLL into the user system directory as well. All right, is there any questions? Oh, there's no questions. That's great. I like this.
There are questions, I'm just not sure what to ask.
That's fair. Okay, there's one back there. Okay, so the question is, you could use a mutex to check if your other instance is running, but then how do you switch that other instance? So there are several ways. You can open up an IPC socket that listens, and then if your other instance of your app finds that this mutex is locked, it could communicate with the other app using IPC socket. There's many ways you can tackle that. I believe we even have an example project that might demonstrate some of that. That's a good question. Yes?
I kind of moved away from Windows when Visual Basic came out and they moved to managed code. So I'm going to do it for myself. I wondered if you could elaborate on some of the history. I remember when they first went to the early version of .NET, that the managed side, C# or whatever, you had to time to interrupt, and there were definite performance hits doing that. My understanding from the presentation that we're dealing directly with Tom, and so that there wouldn't be such performance hits, whether there even are now through interrupt. But I thought maybe you could elaborate on this.
Yeah, so the question was, can I elaborate on the history of COM and the .NET framework, if there's any performance issues there? Okay. So the .NET framework, since it's managed, to go from managed to unmanaged is expensive. String handling, memory management, going from managed to managed, there's a penalty cost there. So when we access COM, since it's not managed, so anything that's not managed from a not managed app, there's no performance hit. So the only performance hit is when managed calls unmanaged or unmanaged calls managed. And there's some marshalling that needs to go on to convert that string into managed code and vice versa.
Okay, so one word to rely heavily on Tom from the managed environment would be a disadvantage to doing the same thing using right?
Right, yeah. Yeah, so there's some penalty cost there when they interrupt. You know, that reminds me, I didn't show you the demo of a WPF control. Oops. Okay, I just start a new project here. So we created this plugin, which essentially adds a WPF calendar and a rich text box. So I'll just add these two here. So again, this is just a plugin we created, a Xojo plugin that accesses the WPF.NET control. And so in terms of the UI, there's not much performance hit, right? It's when you start sending strings back and forth. That's when we get into optimization issues. So with WPF controls themselves, embedding them onto your Win32 app is perfectly fine. You're not going to find it to be slow at all. It's when we start using maybe their dictionary class and we try to use it in Xojo, going back from managed to unmanaged. There's going to be more of a hit there because all these strings need to be converted, all this memory needs to be created. So in this particular case, embedding WPF controls onto your Win32 app is not going to suffer any performance issues. All right. Was there anything back there? So the question is, with Direct2D, is there a way to access the graphics handle of it? Currently, no. Mainly because I didn't find that it was really necessary or useful, but there is a way that I can expose it. What I would expose is the Direct2D render target handle or interface. And with that, you can draw directly to the graphics. But there are some edge cases where things might not draw correctly depending on if you mix your own drawing with our drawing. And that gets a little scary or hairy. But yes, there is a way we can expose it. We just didn't find that it's all that useful. So we haven't yet. Okay, that's good to know. Yes?
I create Windows apps which I put in the Windows Store using the desktop converter, and it builds a manifest file. I think in the latest Xojo, you automatically create manifest files or something like that?
Yes.
Like, what's changed in Xojo to help us put stuff in the store?
That's a good question. So the desktop app converter, I just found this out recently. It only works for Pro and Enterprise. If you have Windows Home, the desktop app converter is not going to work for you. But in terms of how Xojo helps with that transition to using the desktop app converter, we do add a manifest to Win32 apps now. So I'm not entirely sure how the Windows app converter works, if it parses the manifest and pulls out certain values. If it does, maybe it's better now. But yeah, I'd have to use it to probably understand more about it. Any other questions? All right, well, thank you.